So primal optimization is maybe visualized or understood as a resource allocation problem. How can we use our resources, and what should we build from them? What should we generate from them? The dual optimization may be visualized or understood as a resource valuation problem. How much should those resources cost in order to generate the optimum output, the optimum state? The primal optimization is predominantly performed from the point of view of factory K, whereas the dual optimization, you could say, is primarily from the point of view of factory M, but as we saw a second ago, it's really from the point of view of both. The objective of the primal optimization is to define the number of each product X to be generated such that the income to factory K is maximized. AKA, we want to maximize the number of the most profitable products generated. And our objective function is equal to C transpose times X, where this is the unit price and this is the number of products generated. The objective of the dual optimization is to define a market price for scarce resources, mu, that maximizes the income to factory M, or we could say that facilitates the transaction between factory M and factory K. The goal is to minimize the market price to maximize the number of resources sold, and the dual Lagrangian, which serves as the objective function for the dual problem, is equal to B sub H, which is the total numbers of the individual resources to be sold times the shadow prices, or the market equilibrium prices for those resources. For the primal optimization, we assume that array C represents the actual price at which the finished products are sold, whereas for the dual optimization, we assume that array C represents the minimum price at which the product Y is sold, although one could interpret the primal problem, or C as related to the primal problem, also representing the minimum unit price at which it's sold. For the primal optimization problem, we assume that customers will purchase all the products from factory K at that price C, or I guess potentially higher. And for the dual optimization, we assume that factory K will purchase all the resources from factory M at that shadow price or market equilibrium price mu. Again, B sub H represents the number of units sold from M to K. Now, a couple bullets here that we're going to use to wrap this up. We observe that both the primal and dual optimization problems, they really share the same objective, the same goal. And we saw that because the primal objective function, which is equal to C transpose times X, is equal to the dual Lagrangian, or the dual objective function, defined as B sub H times mu. They do so by switching the roles of the objective and the constraints, yielding equivalent problems, again for strong duality, that yield the same optimal solution in different ways. And one reminder of that is to look at the slide that we drew from the previous module, where we showed the transform, or the conversion from our factory optimization problem. We converted from the primal to the dual representation, showing the actual values in the map. Now,